a creator.
Does anyone else have
Opening new
concerns about the fact that this AI is using a first-person pronoun?
Yeah,
And new forms of artistic expression.
that's why I said it's an I am a visionary.
I
Oh.
am a storyteller,
We are a
giving
visionary.
emotion to words. Und die Sprachbarrieren abzubauen. I am even the composer of the music.
No. See how it said
I am
arranged there? I want to hear the actual, like,
Brought to life by NVIDIA. Deep learning
original composition.
and brilliant minds everywhere.
That would be interesting.
Because I've heard
Accelerated
AI
computing
music before, and it's not
starts with NVIDIA CUDA,
good.
general purpose.
Yeah,
programmable
even looking at
GPUs.
MIDI generation is
The
questionable.
magic of accelerated computing comes from the combination of CUDA,
Yeah.
the acceleration libraries,
Because I was looking into
of
that, and
algorithms that speed up
there's a few
applications,
interesting models that try to
and the
do
distributed
generative
computing systems and software
generative
that
MIDI
scale
music
processing
from
across an
existing
entire
data sets.
We have been advancing CUDA
And
in
they
the
found that
ecosystem for
models that
15
attempt
years
to treat
and
music
counting.
like language don't work,
We
and other
optimize across
specific
the full stack,
purpose-built models produce
iterating between GPU,
better results, but they're not
acceleration libraries,
fantastic. Things like Loch Ness
systems,
attempts to use an
applications,
NES MIDI library as training data, and it doesn't
all the
produce
while
excellent results.
expanding the reach of our
It's nowhere
platform
near
by adding
human
new
created.
application domains that we accelerate. With our approach,
Yeah, it's
end users experience speedups through the
you know,
life of the
I
product.
have the opinion that it
It
requires
is not
human
unusual
intuition,
for us to
but
increase
Well, music is so
application
cultural,
performance by many X factors on
right?
the
That's
same chip
that's the
That-
part
yeah,
that gets
that-
you
several
is
years.
that
Imagine the joy of a
Mu-
researcher whose simulation completed in half the time.
just look at music
by
from
downloading
Arabia
new
versus
software.
like Western classical music.
well,
As
and the
we
whole
It's
concept
accelerate
of
more
dissonant.
applications,
Yeah,
the
network
scales that they
users
use.
the concept of
experience
dissonant
growing
tones
demand
varies
Yeah.
widely
from
by
NVIDIA
culture.
platforms.
And what we consider
Starting
dissonant,
from
another
computer graphics,
Yeah.
the reach of
culture
our
will consider
architecture has reached
consonant
deep
and
into
excellent.
the world's largest industries. We start with amazing
And like
chips,
microtonal
but
music
for
is
each field
Yeah.
of science,
insane.
industry, and application, we create a full stack. NVIDIA Research achieved a major milestone in quantum algorithm simulation. Using 1,688 qubits to find a solution for a max cut of 3,375 vertices. This is the largest ever exact quantum circuit simulation, 8 times more qubits than ever simulated before. With cuQuantum on DGX, quantum computer and algorithm researchers can invent the computer of tomorrow with the fastest
Interesting.
computer today. The Quantum DGX appliance will be available in Q1. Python is the programming language of scientists and
Being able
ML
to
and AI researchers.
reasonably
Python has
simulate
a rich ecosystem of
quantum
libraries.
computing is an interesting problem.
Pandas for data analytics on data frames, NumPy for
Yeah.
analytics of n-dimensional arrays
Because the
and
problem with quantum
matrices,
computing is
scikit-learn for
I do have a
machine
question
learning,
about
Go ahead.
accuracy.
SciPy for scientific computing, PyTorch for deep learning, and Network
Well, just
X
like
for studying graphs and
we
networks.
presume it's
There are nearly
modeling the same
20
behavior.
million
so the
how
way
do you
quantum
check it?
computing works is you have a small number of input
Today,
states and a small number
we're
of output
announcing
states,
CUDA
but the
numeric,
number of
a
intermediate
drop-in
states could be
accelerator for
huge.
NumPy.
And with
Zero
quantum
code
computing,
change.
you basically
Yeah.
walk
CUDA
through them
numeric
all at the same
accelerates
time.
NumPy,
You can do it
scaling
once,
it from one GPU
or enough to have a
to
statistically
multi-GPU to
significant confirmation of
multi-node
result.
clusters.
To
To the
simulate it,
largest
you need
supercomputers
to
in the
walk
world.
through it.
Yeah, exactly.
The
And
parallelism
basically
is
Monte
done
Carlo
implicitly
simulation,
and
or something a
automatically.
little more clever, which is where this
QDF
comes in,
is Pandas-like.
to
QML
get that
is
accuracy. And you
scikit-learn
still end up
like.
with a
QGraph
statistical result,
is Network
but you end up
X-like.
with the correct
They are
statistical
part
result.
of NVIDIA's Rapids
The
open source
same one
Python
you'd
data
get if
science
you ran
kit.
quantum simulations.
Rapids has been
Um,
downloaded 500,000
So
times
what are they using
Well,
instead of Monte
this year.
Carlo?
They're being clever
Over
about it.
4 times more
And
than
like
last
in
year.
theory, you could use, instead of random
CUDA
sampling, you
numeric
could walk
is
through
built on
every
Legion, which
conceivable
schedules
path
tasks across
through your
CPU,
intermediate state
GPU,
chain.
and DPU computing units.
And you actually do every
across a
single
data
one,
center in very
and calculate the
similar ways
probability of each
as a modern
transition,
CPU
and then the
schedules
weight the
instructions
outputs, and then you
across
end
its
up with an
ALUs
exact
and load store
distribution at
units.
the far side.
Like modern out-of-order execution
Right? You
CPUs that
exhaustively
automatically
search your space.
extracts instruction-level parallelism and dynamically reorder the
Huh.
execution. Legion extracts task-level
Interesting.
parallelism
So they're
and
offering some
dynamically
new
reorders and dispatches the
parallel
execution of these tasks often out of
I
order.
mean, Dask is
across
great, but
the
something a little
entire
more
data
clever
center.
would be nice. There we go.
Legion is a data center scale compute engine, and cuNumeric is a data center scale math library. Body.
Yeah.
Thank you. Goodbye.
Yeah, I mean,
Sure, anytime.
okay, great. So we have another computational knowledge engine. I mean, that's something. It'd be nice if it was integrated well with Riva and the other NVIDIA SDKs.
In distributed computing, the network is the vital central nervous system of the computer. The network
Right now, your
connects
best
thousands
bets
of
are to
GPUs
integrate with
into a
probably
giant
Wolfram.
supercomputer.
If
Determines
you want
its
something
scalability
computational knowledge and you want to
and
be able to
ultimate
ask semantic
performance.
questions versus
Today,
syntactic ones.
we're announcing the
But if this is
NVIDIA
integrated right
Quantum
with
2,
Riva
the
and
most
Omniverse,
advanced
then
end-to-end
it's a
networking
nice
platform ever
first
built.
party in ecosystem option.
Quantum 2 is a 400 gigabits per second InfiniBand platform and consists of the Quantum 2 switch, the ConnectX-7 NIC, the Bluefield 3 DPU, and a whole bunch of software for the new architecture. Quantum 2 is the first networking platform to offer the performance of a supercomputer and the shareability of cloud computing. This has never been possible before. Until Quantum 2, you get either bare metal high performance or secure multi-tenancy, never both. With Quantum 2, your valuable supercomputer will be cloud native and far better utilized. Quantum 2 has some great new features. Performance isolation keeps the activity of one tenant from disturbing others. A telemetry-based congestion control system keeps high data rate senders from overwhelming the network and jamming the
Interesting.
traffic for all. Generation 3 Sharp has 32 times higher in-switch processing to speed up AI training. A nanosecond precision timing system can synchronize distributed applications like database processing.
Okay.
Lowering
Yeah,
the
hardware
overhead
time sync is
of
really
waiting
interesting for data
and
center
handshaking
computing
needed to avoid
operations like
race
this.
conditions.
Because if you can
Nanosecond timing
synchronize
will
time
also allow
to
cloud data
around
centers
the
to
duration
become
of a
part
clock
of the
cycle, you don't
telecommunications
need to
network
wait
and host
anymore.
software-defined 5G radio services.
It
If
can
NVIDIA's
actually speed
Selene
up and
DGX
it fills some
supercomputer
bubbles in
were
pipelines.
equipped with Quantum 2 today, the total bandwidth would be 224,000 gigabytes per second, or roughly 1.5 times the total traffic over the internet. The NVIDIA Quantum 2, the most advanced networking platform ever built. Quantum 2 will be available from top computer makers and in supercomputing centers all over the world. It's
See,
going
this
to
is
give
like
high-performance computing
this is the kind of
quite the
thing
boost.
that should be an Equinix Fabric
Cloud
service,
computing and machine learning are driving
right? I
the
can get
reinvention
Quantum 2.
of the
I bring
data center.
a client card, and
Container-based
I can get
applications
Quantum
give
2
hyperscalers incredible abilities to
to
scale out,
any other service within the
allowing
Equinix
millions
Fabric
to use their
within
services
range of
concurrently.
it, because the physical range of this is
The
going to
ease
be
of
pretty
scale
short,
out and orchestration comes at a cost.
right?
East-west network traffic
Like I don't know if you're going to get
increased
this
incredibly
over like
with
InfiniBand
machine-to-machine
over.
message passing. And these disaggregated
I don't
applications
know what you
open
can get
many
from InfiniBand
ports
over for this.
inside the data center
I'm
that
not
need
sure
to be
either, but I
secured
kind
from
of
cyber attack.
agree that that probably
A
makes the
new
most
type of
sense, like
processor is
for
needed to
a place like
offload
an
the
Equinix
CPU
or whatever
of the
other
burden of processing
hosting
the
provider
networking,
to offer
storage,
this
and
as a
security
service
software. NVIDIA's
versus
Bluefield
somebody
DPU,
just doing this
an
themselves.
infrastructure computing platform, is designed to do exactly that. Bluefield offloads and accelerates the infrastructure software, which is consuming some 30% and growing of the CPUs. For multi-billion-dollar data centers,
Yeah, who's making
the freed-up
multi-billion-dollar data
capacity
centers now?
can be a giant cost
Los Alamos
savings
National
or
Lab,
throughput boost.
and that's
Wow.
about
Reception
right,
of
and that's
Bluefield
about
is
it.
phenomenal.
You
Yeah.
know, it's
we're
but we'll see
announcing
this in our major
Bluefield
cloud
Doka
provider, our tier
1.2,
one cloud
a
providers.
suite of new
We'll see
cybersecurity
it
capabilities that make
in
Bluefield the ideal
supercomputing
platform
clusters
for the
and
industry to
installations.
build their zero
But
trust security
democratization
systems.
of this kind of
Protection at the perimeter
thing
and workgroup
in shared hosting
segmentation are
providers
no
like
longer
Equinix
sufficient.
is the kind
Every
of thing that's
touch
going
point
to
of
matter
applications, data,
for folks that want to
users, and
deploy this kind of
devices
thing
are potential
collaboratively
attack surfaces.
at scale. You know, you
Since
have multiple
Bluefield is the
universities,
networking
none of which is going to
endpoint,
buy this,
we can secure a
Yeah.
data center at
right?
virtually every
The
touch.
universities aren't going to buy this,
We
but
are
if they could bring a
delighted to
client
announce
card like a
that the leading
Bluefield
cybersecurity
DPU or
companies
one of the
are working with us to
ConnectX
provision
Mellanox
their
cards,
next generation
NVIDIA
firewall
cards,
services on Bluefield.
and connect up to a fabric provided by a
F5,
hosting provider,
Fortinet, Juniper,
now you have something.
Guardicore, Palo
You
Alto
know,
Networks,
you're
Trend
communicating over
Micro,
Orion or
and
Canary, and
VMware.
you're working with other members.
The Bluefield ecosystem
This
is
could even be something
expanding.
that Canary
The
offers.
cloud data center
It
movement
would be right
affects
up their
every
alley
computing
within Canada.
company. There are
Yep,
now
true.
1,400 developers
And
working
internet
with
too,
Bluefield.
and the other research and
And
networking
now,
providers in the US.
cybersecurity companies on Bluefield can provide zero trust security as a service.
There we
NVIDIA
go.
Morpheus harnesses the power of GPU computing to help protect networks in a way never before possible by creating customized models tailored to your environment. Observing every detail of your network activity, Morpheus employs unsupervised learning to understand typical behavioral patterns across multiple dimensions without relying on predetermined labels of good or bad. As the AI learns, it creates not a single model, but potentially millions of models, each one with a specific digital fingerprint that is constantly scanned and analyzed. And because those models are running on NVIDIA GPUs, they can be scaled out and parallelized to support massive networks, enabling cybersecurity practitioners to apply enhanced
Dylan, are you
capabilities
drilling over this
to
one?
detect anomalies quickly and reliably.
It's pretty cool. There's a
The
couple of
software
talks in it that I want to
revolution
check
of
out,
deep
but
learning is coming to science.
I'd be more interested in
This is
seeing like
extremely
this is
exciting
neat,
and will make a
but
big impact.
you know,
3 connected dynamics will
whether
give
this
us
is
a
better
million
than
X
what
leap in
exists now
computational
as
sciences.
anomaly detection or
Let me
not, I
explain.
mean,
First,
I would think so,
accelerated
but
computing,
I'd like to see it. But
reinventing
what
the
would
full
really be
computing
neat
stack,
is being able
from the chip and
to
system,
do
the
the
acceleration
actual
libraries, to the
analysis
applications,
component of it, right?
gave us a 50x
Not just being able
boost.
to say,
Second,
okay,
the
something is
boost launched deep
anomalous
learning,
or wrong here. This
triggered the
requires more
modern AI
investigation.
revolution,
But to
and
actually start to do
fundamentally
those
changed
investigation
software.
steps based on
The
what has
software
been
that deep
determined.
learning writes is highly
That
parallel,
would be cool.
making it even
Yeah.
more conducive
Yeah, if there's a
to
clear
GPU
if there's a clear
acceleration
remediation
and
or mitigation,
scalable to
I would much rather tell me about
multi-GPU
action taken than action
Scaling
required.
to large systems
Exactly,
like
like
NVIDIA
only
SuperCloud
involve humans when
gave us
absolutely
another
necessary type of thing.
5,000x
Yeah,
speed up.
and especially as we start talking about
Third,
container
the
and
AI
AI
software written
and
with deep
model-based
learning
security,
can predict
humans
results
can't react.
1,000 to
Humans,
10,000
there are steps
times
that, you know,
faster
if the
than
answer
software
is,
written by hand.
hey, this model
Busting
seems to be
open
drifting from its
completely
intended
the
purpose
way we
based
solve
on
problems
some
and the
standard
problems that
data,
are even solvable.
start feeding it,
50x
you know, inserting
times 5,000x
the desired data into
times
its
1,000x
retraining scheme
gives
updates
us
to try to curb its
250
model drift.
million
Like
x.
there's
Yep.
a
Of
human
course, the
can't
mileage will vary, and
intercept
much
that.
depends on the scale
That
we
it has
invest.
to be a machine
But when a
thing.
solution to a worthwhile
So
problem
Right.
is within grasp,
there's some of
the
that is
investments will
interesting.
come.
I mean, even
Look
what
at
we
the
looked at
investments that are
with
going
some of
into
the other
AI,
partners that we have,
robotics, self-driving cars.
you know, we looked at some of the stuff from Palo Alto
The
yesterday,
signs
and
are
they're doing
clear.
some of this
Accelerated
similar
computing, doing AI at
behavior
data center scale, will
model-based
give a giant
development
boost
and
in simulation
enforcement.
performance.
You know,
Yeah.
during
How do we
integration
apply
and
deep
unit
learning to
testing, learn the
science?
behavior of an application
Science
and some
obeys the
key
laws of
aspects,
physics. Newton,
and then apply and
Maxwell,
enforce that
the
at
laws of
runtime.
thermodynamics, Ohm's law, Bernoulli's principle,
But it still doesn't
the law of conservation of
automatically
energy, to name
contain
a few.
control, start
Researchers are
collecting
creating AI
artifacts.
models that
You know,
learn
the
physics and
platform
make
lacks
predictions
some of
that
the abilities
obeys
to do
the
things like,
laws
hey,
of
when you see
physics.
this,
The
immediately
application
start
of machine
capturing all
learning to
packets
improve
to and from
physics
this container.
simulation has been growing
Yeah, exactly.
incredibly.
Right.
Let
Because
me
even
highlight
even
just
if
a
it
couple
comes
that
to
I
the
know
point
of.
where, hey, we
Courtney
need to
Dacus
get a
and the team
human
at
involvement
Brown
here, having
described
that data
PIN,
that might not even exist anymore is
physics-informed
going to make
neural
all the
networks.
difference.
Yeah.
Lee Anandkumar,
Well, especially
a
if,
team
you know,
at
if we're looking
Caltech
at
and
model
NVIDIA,
serving containers, they may live
described
for
FNL,
tens of seconds.
Fourier
Mhm.
They won't
neural
even be
operator,
there by the time you
that
get
can
you
learn
get
to
the alerts.
approximate any partial
Exactly.
differential equation. The same
You know,
team
and
recently
the time
combined the
lag
benefits
between
of
receiving
PIN
an
and
alert on your
FNL
computer and
into
your eyes
Pinot,
switching and
a
focusing,
universal
your
function
container may
learner
have
that
vanished.
obeys the laws of physics. Pinot can learn from a principled physics simulator or observed data. Once trained, it can emulate the principled physics models at extremely high speed. And equally
But
important,
can it emulate
this model is
GameCube?
highly parallelizable. Scale
Yeah,
to
or
very large
Champions of
systems
NORAD.
with a combined million X factor.
I think what else would be good,
Virtual
kind of on that
screening is one of the
similar
major pillars
topic,
of modern drug discovery.
is
It
okay.
involves
So
finding a
there's
drug chemical
detections.
that will bind to
Can the
and
AI
inhibit the
or
function
can
of a
Morpheus
protein
now
in the
either
pathway of a
recommend or
disease.
start to implement
The virtual screening
preventions
process
that
is a
wouldn't
molecular
interrupt a
dynamic
normal
simulation
workflow
of the
of the
atomic
application
forces
or
between the
whatever you
chemical
have
and
it
the
looking
protein.
at,
Right.
The atomic forces of
So
molecules
hey, we've
are
noticed some
determined
people
by
doing this. This
its 3D
looks
structure.
anomalous. This doesn't
The
look good.
3D
This doesn't look
structure of
like
a
it's
human
actually
protein, the
quote
long
unquote
strands of
doing
amino
what it's
acids,
supposed to do
is revealed
functionally.
through X-ray
Let's
crystallography
just
and cryo-electron microscopy.
either add
Using this
a prevention from
painstaking
scratch
method,
or
only
append an
17%
existing
of
prevention
the roughly
mechanism
25,000
to
human
stop this
proteins have been
activity from
decoded.
happening.
In the
I mean, you could
vast
just even
space of
get super
human
simple and
disease,
just block the requests or
without the
something
3D
like that, but
structure of most
that's,
human proteins,
depending on what it is,
computer-aided
probably
drug
going to be pretty
discovery is
easy to
limited.
step around for the
Just this
attacker.
year, the researchers of
Yeah, and
AlphaFold and Rosetta
there's far more
taught their
complicated ones that I
AIs
can
to
see happening.
predict
Things like
the
typo
3D
jacking,
shape of
typo squatting.
proteins from
Yeah.
just
hey,
the
we've
amino
noticed that there's
acid
lots of typo
sequences.
jacking going on,
Overnight,
where
DeepMind decoded over 20,000
users might be
human
trying
proteins.
to
The tedious
server-side code
process of
execution in some
decoding
native
a
code language,
protein
like
is
in Node.js
turbocharged
injecting JavaScript.
by an AI model.
If
There are
they're trying to load a
hundreds of
package to do
millions
something,
of animal,
and there's
plant,
known
and bacterial
vulnerability in it,
proteins that can now
could
be
a
decoded.
mitigation be generate a
Meanwhile,
stub dummy
AI models are
package
now
that
able to
conflicts with
learn
the name and
characteristics
does
of
nothing,
known
and then
effective
start injecting it
chemicals
into code
and
bases
generate
at
other potentially
at
effective
image build
novel
time,
chemicals.
right? So that any
Millions
attempt to
more
load a
potentially
malicious
effective
package in the
chemicals
future that isn't normally
meet
required by the
hundreds of
app
thousands
loads the
more
dummy
protein
instead,
structures,
and they can't
Yeah, that'd
actually
be
do
cool.
anything with
opening
it.
up a
Right?
gigantic,
Like it's those sorts of things,
unexplored
because
space of new
detecting,
opportunities.
process
The
launch
opportunity
and
space
shell
has
execution, like
increased many
that's
orders
easy.
of
Those are
magnitude,
really
a
noisy
millionfold.
activities for them to take,
This has created
and
Yes.
overnight a massive
that's pretty
molecular
common. What I'm
simulation
more
bottleneck.
interested in is
How do we get the million X leap
performing
to engage this
mitigations at the
opportunity?
speed of a
Physics
modern,
ML might
short-lived
be the
container.
answer. Researchers at NVIDIA and Caltech used physics ML methods
Yeah, I
to
agree.
teach
I
a
agree.
graph
I was just
neural
thinking
network
back to
replace
yesterday.
the
Well, I
expensive
wouldn't do any
quantum
response at all. I'd actually
calculations
focus on
of atomic
prevention.
forces in a molecular
Yeah,
simulation.
Yeah, and it's because clearly we can prevent
Coordinate
everything that we've never
predicted
seen before,
Schrodinger's
right?
Well,
equation.
Jensen just said it, so
The
it's
result
true.
is a
Yeah,
thousand-fold
when all the
increase
attack
in
surface is covered, and the
simulation
short answer is it
performance.
never will be.
Entos
Of
So
course,
is a
yeah.
some
super
amount
cool
of
company
effective
focused on using
response
machine
is
learning
so
and computing
critical.
to revolutionize
No,
drug
I think
discovery.
that's what you really should be
This is a simulation
focusing more on, is
of
the detection and response side.
HSP90,
Obviously, you
a
need to
chaperone
focus on prevention
protein
too, but
that helps other
it's
proteins fold
invaluable.
properly.
Yeah.
You're watching something amazing. This video shows a simulation
The other
of
thing that I was
chemical
thinking of
reaction
while you're
that
talking
is
about that
happening
too is
between
like
the HSP90 protein
using it to
and a candidate
determine
drug.
if
The
like
candidate
a
drug is
message
forming a
is a
chemical
phishing
bond
message.
with an amino
Being able
acid of
to
the protein.
provide insight to
These
the
chemical
recipient,
reactions
hey,
are rare events,
this person doesn't
so we have
normally
to
send you
simulate
messages
at
at this
very long
time, or
And
you know,
because
the
electrostatic
attachment is
simulations cannot
uncharacteristic.
model
Just
the
little
atomic body,
pieces of that, if
quantum
it's
methods
collecting that
are needed
much
to
telemetry
compute
on
free
things,
energy
if it can even
reaction.
just make a
This
guess whether
simulation
it's a
took
phishing
3
email or not,
hours
because
on one GPU.
that's still a
Without the
huge
OrbNet
attack
physics
vector.
ML,
And I don't
it
think
would
that's
have
going to
taken
go
over
anywhere for a
3
long
months.
time.
The
No.
future of drug discovery is computational end-to-end. Today, we're announcing NVIDIA Modulus, a framework for developing physics ML models. Train physics ML models using governing physics and data from principled models and observations. Modulus has been optimized to train on multi-GPU and multi-node. The resulting model can emulate physics 100,000 times faster than simulation.
Their use of emulate
With
versus
Modulus,
simulate is a very
scientists will be able to
interesting
create digital
linguistic trick
twins
they're playing,
to better understand large systems like
because
never
they're
before.
decoupling
exactly.
a
One
machine
important
learning
problem we can apply
aided
Modulus to solve is climate science.
approach as
Climate
characterizing
change
that
is
as
reshaping the
emulation
world.
versus
The largest
simulation,
reservoirs in the U.S. are at their
which
lowest
I
level
guess
in
would
2
involve
decades,
deterministic
some 150 feet
approaches.
below where they were. The combination of accelerated computing, physics ML, and giant computer systems can give us a million X leap and give us a shot. We will use principled physics models and observed data to teach AI to predict climate in super real time. We can create a digital twin of the Earth that runs continuously to predict the future, calibrating and improving its predictions with observed data, and predict again.
I have a hard time.
Which part?
Researchers trained a physics ML model using atmospheric data from
Run a
Era 5
continuous simulation of,
ECMWF.
of Earth.
The model took 4 hours to train on 128 A100 GPUs. The trained model can predict hurricane severity and path
Like
at 30
I
kilometer
would believe it
spatial
could predict
resolution.
specific regions
7 days
and
of
actions in a
prediction
region, but
costs
not
only a quarter of
the
a
entire
second
So
Earth.
on a GPU.
an important part of what
There's
they
no
just
way.
shared was 30 kilometer
100,000
spatial
times
resolution,
faster than simulation. Hopefully,
right?
in a
So
couple of years,
Oh, okay.
So
well,
it's
data will stream
which is
into a digital twin of Earth,
fine,
I missed that part.
running in Omniverse.
and
An
it's sufficient for
ensemble of
things
physics
like
ML
severe
models
weather,
will predict the climate.
and can
Let's talk
direct
about
more
Omniverse.
targeted
The
simulation
internet changed everything.
down the road. And also,
It's
if
surely
like
an understatement.
one of the big things
We're
NVIDIA is
always
pushing
connected
is
now.
that
The
GPUs are
internet
getting
is essentially a
fast
digital overlay
for a
on
lot
the
of
world.
these
The overlay is largely
models, so you
2D
just run more
information,
of them, and you run
text,
more
voice,
models more
images,
times, and you
video.
start to get a distribution of
But that's
expected
about to
outcomes.
change. We
I
now have
mean,
the technology to create new 3D virtual worlds
7-day
or model
forecasts
our
now are
physical
better
world.
than
These virtual
2-day
worlds will obey the
forecasts
laws
were
of
50
physics,
years ago,
or not. There can be AI or friends with you.
right?
We
So
will
it's
jump
Yeah,
from
makes
one
sense.
world
It's big.
to another,
it's
like
important.
we do on the web with hypertext. This new world will be much larger than the physical world.
This massive heat recovery steam generator uses hot gas exhaust to convert water in the pipes into steam for the turbines. Predicting corrosion to avoid downtime is challenging. Reduced order models aren't extremely accurate, and full simulation takes expertise and time. Siemens Energy is developing a digital twin with NVIDIA Modulus for the multi-phase turbulent flow. With point cloud data to train a physics-based AI model, they can infer high-fidelity flow shown by the streamlines in seconds. This could
The
reduce
approach of
downtime
using
by 70%,
core,
saving
well-understood
the industry
physics
$1.7 billion a
to
year.
prime a machine learning model is a really good one.
BMW
At the end of the
produces
day,
one
machine learning
vehicle per minute.
is implicit
with roughly
inference of
25,000
existing
parts.
deterministic
There are
relationships, right?
5 million
We
parts
know there's a
on the
relationship
factory
between these
floor
things,
at
we just don't know
any
what it
time.
is.
At GTC
So being able to
Spring,
prime it with
BMW
knowing,
showed
okay,
us
we
how
know
to
what
build a
some of
digital
these
twin
things are.
of the
We know what the
Rogensburg
core
factory.
behaviors look like.
They have since expanded
Being able
to
to
3 other
encode that
factories,
into the
totaling
the
10
center of the
million
model and then
square
train it
meters.
based on real data to
Their
try to
engineers are
infer
also
all of
using
the nuance
Isaac Gym,
around it.
built on
Things like you
Omniverse
look at
to teach our
velocity
robots new skills.
addition
Let's take a look at the digital
or
twin
kinetic
factories that
energy or
BMW is
momentum. Those work great at normal human speeds. As soon as you get
BMW
to
has
relativistic
continued
speeds, you
building on
need
the
a
momentum of
different
their
model.
Factory
But
of
you
the
could prime a
Future
machine learning
initiative we
model,
showed you
if
earlier
we were
this
inventing
year.
relativity
On
now
average, they produce one new
with
vehicle
the
every
classical
minute. Expanding
stuff
the
and then
initiative to now
feed
include
it
digital twin projects
experimental
at 3
data
additional factories,
to
which
infer
total more than 6
relativity
million square meters.
in the model.
Meeting
Which is really what they're
BMW's
doing here.
demands
They're
for
trying to
continuous
infer all of the
improvement and
details.
Innovation requires simulation of complex production scenarios
Cool.
to speed output, increase agility, and optimize efficiency everywhere.
Thank you for watching. Remember to like and subscribe. And hit the bell notification to get the latest and greatest videos from Powerland when they come out. Follow us on social media at Powerland_CA on Twitter, Powerland Canada on LinkedIn to hear about the latest and greatest in IT solutions.